Welcome to Copilot Podcasts. Right now, there are probably dozens of sensors within arm's reach of you, silently measuring, monitoring, and making decisions. Today, we're diving into the fascinating world of sensors, signals, and systems in data acquisition. By the end of this episode, you'll understand how these invisible guardians shape our modern world.
It's amazing how far we've come from the simple mercury thermometer to today's sophisticated sensor networks.
Wait, mercury thermometer? That's an interesting place to start.
Yeah, see, the mercury thermometer was one of our earliest sensors. It converted temperature into a visible measurement. But unlike modern sensors, it couldn't output data that could be recorded or analyzed digitally.
So, what exactly makes a modern sensor different?
According to recent research, a sensor is essentially a device that detects changes in the environment and converts them into measurable analog voltage or digital signals that can be processed further.
Ah, so it's like giving machines a way to sense their environment?
Exactly. Think of sensors as the consciousness of machines. They make technology aware of its surroundings, just like our senses do for us.
That's fascinating. What are some common types of sensors we encounter daily?
Well, there are temperature sensors, pressure sensors, proximity sensors, accelerometers. Each type is designed for specific measurements.
And these all feed into what we call data acquisition systems, right?
Right. A data acquisition system typically consists of sensors, signal conditioning, analog to digital converters, and computer systems for logging and analysis.
You mentioned signal conditioning. What's that about?
Signal conditioning is crucial. It's about taking the raw sensor output and preparing it for conversion to digital form. This might involve amplification, filtering, or other processing.
I've heard the sensor market is growing rapidly. What's driving that?
According to recent statistics, the global sensor market is expected to grow at an annual rate of 8.4% from 2023 to 2032, reaching about 508.64 billion UAS.
That's a massive number. What's driving this growth?
Interestingly, one of the biggest drivers is the automotive industry. With the rise of electric and autonomous vehicles, there's an increasing demand for precise sensor technology.
So, cars are basically becoming rolling sensor platforms?
Exactly. Modern vehicles use sensors for everything from tire pressure monitoring to autonomous driving features.
Let's talk about how these sensors actually work with systems. What happens after a sensor detects something?
Well, sensors work in a system alongside actuators. The sensor signals are typically forwarded to a control unit, which analyzes the data and sends commands to actuators as needed.
Can you give us a practical example?
Sure. In a smart factory, temperature sensors might detect that a machine is running too hot. The control system then activates cooling systems to prevent damage.
That makes sense. Are there different categories of sensors we should know about?
Yes, sensors are broadly categorized as either active or passive. Active sensors generate their own signal for measurement, while passive sensors detect existing environmental conditions.
Can you give examples of each?
A laser distance meter is an active sensor. It generates a laser beam for measurement. A PIR motion detector is passive. It just detects infrared radiation from moving objects.
Interesting. And how do these connect to the whole signals and systems aspect?
Well, signals are how sensors communicate their measurements. These can be continuous or discrete, and systems are what process these signals to make them useful.
So there's quite a bit of math involved, I imagine?
Yes, signal processing uses various mathematical tools like Fourier transforms and differential equations to analyze and manipulate these signals.
That sounds complex. How do we make sure all this technology works reliably?
Actually, adding more sensors often makes systems more reliable, not less. It's like having multiple senses. If one fails, others can compensate.
That's counterintuitive. Can you elaborate?
Think about autonomous vehicles. They use multiple types of sensors: cameras, radar, LiDAR. If visibility is poor for cameras, radar can still function perfectly.
What about the future of sensor technology? Where are we headed?
The trend is towards smarter, smaller, and more energy efficient sensors. We're seeing increased integration with AI and machine learning for better data analysis.
Speaking of machine learning, how does that fit in?
Machine learning helps make sense of the massive amounts of data these sensors collect. It can identify patterns and predict potential issues before they occur.
Like predictive maintenance in factories?
Exactly. A recent case study showed how a global auto manufacturer used vibration sensors and ML to predict equipment failures, significantly reducing downtime.
That's impressive. What about challenges in the field?
One major challenge is dealing with noise and interference in sensor signals. That's where good signal processing becomes crucial.
How do we handle that?
Through various filtering techniques and sophisticated algorithms. It's like cleaning up a radio signal to hear the music clearly.
Are there any emerging applications we should watch for?
Healthcare is a fascinating area. We're seeing development of wearable sensors that can continuously monitor vital signs and predict health issues early.
That could really transform preventive healthcare.
Absolutely. According to recent studies, these systems can monitor everything from heart rate to blood oxygen levels in real time.
What about environmental applications?
Environmental monitoring is huge. Smart agriculture uses soil moisture sensors and weather sensors to optimize irrigation and crop management.
So sensors are really helping us become more sustainable?
Definitely. They're crucial for efficient resource management and reducing waste across industries.
What advice would you give someone looking to work with sensors?
Understanding the basics of signal processing and system integration is crucial. Start with simple projects and gradually increase complexity.
Any common mistakes to avoid?
The biggest mistake is not considering the entire system. Sensors don't work in isolation. You need to think about power, processing, and environmental factors.
That's really helpful. As we wrap up, what's the key takeaway about sensors and data acquisition?
Sensors are fundamentally changing how we interact with and understand our world. They're the bridge between physical reality and digital intelligence.
And they're only becoming more important, right?
Absolutely. As we move towards more automated and intelligent systems, sensors will be crucial for safe and efficient operation.
It's amazing how something so small can have such a big impact.
That's the beauty of sensor technology. It's the small things that help us understand and control the big picture.
Well, that brings us to the end of today's episode of Copilot Podcasts. Remember, every measurement, every data point, every automated decision around us starts with a sensor.
And just like that mercury thermometer from our earlier discussion, we're constantly evolving how we sense and understand our world.
Thanks for joining us on this journey through the world of sensors, signals, and systems. Until next time, keep sensing, measuring, and exploring.